Hello friends, today we'll go through the chapter 5 which is over voltages, lightning and insulation coordination. Myself Chandrashekhar S Patil, Assistant Professor from SIT COE Edra. Transients or over voltages. Before we go through the chapter, we'll understand what is a transient or what is an over voltage. Transient phenomenon is a aperiodic phenomenon which does not occur periodically or which occurs randomly and it does not last for a longer duration. Duration for which they last and the operating time of the system is very significant in the study of transients or over voltages. Transients occur if the inductor or capacitor or both are present. In the presence of only resistive element, the transients do not occur, and whereas in the presence of inductor, capacitor or both of them, the transients will be occurring every now and then. Transients occur if a sudden change in the form of a fault or any switching operation should take place. Transients, whenever um, the fault is occurring or the switching operation is taking place, at that point of time, transients or over voltages do occur. Two components of voltages in a power system during transients are: first one, fundamental frequency voltages; second one, natural frequency voltages appear after the sudden occurrence of a fault. So to illustrate how the transients occur in a simple circuit using DC source, for a resistive circuit, the graph is as shown. For an inductive circuit, the graph is as shown in the diagram. And for the capacitance circuit, whenever a DC source is applied, the graph of I versus T is as shown in the diagram. Transients in a simple circuit using DC source. So for RL circuit, whenever there is a resistance and inductive circuit, the transient is occurring, and at that point of time, the current I of t is given by the equation as shown. And for a RC circuit, the curve is as shown here, which is a inverse curve, inverse parabolic curve, and also the current I of t is given by the formula which is as shown in the slide. Also for the RLC circuit, the three elements R, L and C are fed with a DC source, and the curve or the nature of I of t versus t is as shown in the diagram, and the formula for calculating I of t is as given in the slide. Transients in a simple circuit using AC source. Whenever an AC source is applied for a RL circuit, the transients or the asymmetrical alternating currents is as shown, and the I of t is given by the formula which is shown in the slide, and for calculating I of t, theta is assumed to be tan inverse of omega L by R. So next point is lightning. Some of the accepted facts and associated phenomena considering thundering clouds are: the height of the cloud should be between 160 to 9,500 meters. The charge centers which are responsible for lightning are in the range of 300 to 1500 meters. The maximum charge on a cloud is of the order of 10 coulombs and which exponentially increases over a period of perhaps many seconds or minutes. The maximum potential of a cloud lies approximately within the range of 10 megavolts to 100 megavolts. The energy in the lightning stroke may be of the order of 250 kilowatt hour. So, what is a lightning? Lightning has been a source of wonder to mankind for thousands of years. Scotland pointed out any scientific research for the phenomenon of lightning was made by Franklin in the 18th century. Two theories have been proposed to explain the lightning mechanism. One is the Wilson's theory of charge suppression, and the second one is Simpson's and Scar's theory. We'll go through the two theories in the next session. Thank you.